Imagine taking off in one hemisphere and landing in another without stopping and without traveling in an airplane. There's a creature that does this, making a non-stop 7,000-mile journey every autumn. The feat takes 9 days, starting in western Alaska and ending in New Zealand and eastern Australia, making the bar-tailed Godwit one of the most admired long-distance travelers in the world. And one Penn State researcher thinks that large-scale weather patterns may play a crucial role in how this migratory bird makes it happen.
There are 3 days of persistent northwesterly winds, and they go on, typically on the second day. So as soon as I hear about persistent winds, and a lot of my research has been atmospheric dynamics and teleconnections.
Dr. Stephen Feldstein is a retired professor of meteorology and atmospheric science at Penn State. For years, he has studied teleconnections, how large-scale weather patterns are linked across the globe. He's also an avid birder, a hobby that takes him outside looking for feathered flyers. He decided to take this knowledge of teleconnections and combine it with his admiration for the long-distance traveling bar-tailed Godwit.
Birds like Bar-tailed Godwit, their migration is associated with teleconnection patterns. This is a less frequent pattern along the western Pacific. It felt sort of natural to do research in this area. And for most birds that migrate long distance over the ocean are tied to teleconnections.
The bar-tailed Godwit departs from western Alaska from late August through mid-October. Once they take off, they fly over the open water of the Pacific Ocean, crossing the equator, and don't land on their feet until they reach New Zealand and eastern Australia 9 days later, making them one of the longest non-stop migrating species in the world.
I looked into whether convection in the tropics is playing a role, especially with any birds that have gone across the equator, which many do. If you have convection near the equator, it will excite Kelvin waves in the tropics, Rossby waves that propagate poleward in both hemispheres.
The upper-level ridges and troughs you are familiar with here on Weather World are examples of Rossby waves. They're responsible for driving warm air from the tropics toward the poles and colder air from the poles toward the equator.
And then their influence extends down to the surface where we have northwesterly winds. So the birds then will migrate in the southeastward direction from about 60 north to 30 north with tailwinds. And then after that, they'll encounter the trade winds between roughly 25 south and 25 north.
Once the birds get closer to the equator, the effect of Kelvin waves on the bar-tailed Godwit is noticed.
And we can identify the Kelvin by the vertical shear of the zonal wind. And what the Kelvin wave will do, it'll strengthen the trade winds even more. So that'll enable the birds to migrate much more rapidly westward so they can reach the longitude of New Zealand.
The bar-tailed Godwits reside in New Zealand from mid-October through March. They then take a 2-part journey for their migration back north. In early March, they fly non-stop from New Zealand to the Yellow Sea, located between China and Korea, where they spend weeks eating and storing energy. In May, they travel non-stop to their breeding grounds in western Alaska, where they spend the northern hemisphere summer. And while Feldstein has never witnessed the actual migration of the bar-tailed Godwit, he still had a great appreciation when he finally saw one after its arrival in western Alaska.
So when I looked at it, the first thing is just a thrill of seeing a bar-tailed Godwit for the first time. And then I thought about, because this bird is an adult, it's made this journey at least once, and probably many more times. So I just thought, what did it feel like to undergo such an immense journey, probably many times? So that was exciting. So I saw it at the end of migration, near where they actually nest.
While Feldstein's passion for his career, along with his enthusiasm for his hobby, led him to find out more about how weather impacts the migration of the bar-tailed Godwit, he's realized there's much more he wants to learn, including studying the migration of birds flying across the Gulf of Mexico.
I've also started to look at the effect of weather and migration of birds across the Gulf of Mexico. There are many small birds, a lot of warblers, a lot of birds that we see here during spring, summer, and fall, that when there are southerly winds in the northern Yucatan Peninsula, they'll take about a 16-hour nonstop flight to the Gulf Coast of the U.S.
One way he'll do that is by using a common meteorological instrument.
That's determined by using weather radar, in which the meteorological signal is removed, and then one can count the number of birds that are flying across the Gulf of Mexico. And so I'm going to be using that kind of data, using standard meteorological methods to look at this connection between migration across the Gulf of Mexico and the weather, just because we have this high-quality radar data.
Feldstein also has his eye on other research projects involving weather patterns in equatorial regions.
For instance, there's a seabird known as Hawaiian petrel. And the adults, let's say one adult is incubating the eggs on the nest, another will undergo a migration from Hawaii all the way north of 50 North and east to the west coast of the U.S., south to about the U.S.-Mexico border, and then back to Hawaii, just to feed and also get food for its young, about a 10 to 14-day flight.
It's research like Feldstein's that helps us to understand the efficiency and complexity of how the atmosphere impacts the migration of some of Mother Nature's most fearless flyers. For Weather World, I'm Marissa Ferger.